Hello students, this is the first part video on the one-dimensional motion. In this video, we will begin with the introduction to the concept of motion and how do we understand or study the idea of motion. Okay, so we'll start with the basic idea of what we call as rest and motion. Like you can see in the visualization, right? What we have observed is the particular ball before the player has kicked it, it is in a position, okay, and its position is not changing with respect to time. So after he has kicked the ball, what is happening? It is changing its position with respect to time. Okay, so whenever we look at any object, like in this case we are observing this particular ball. So whenever we observe any object, right, if its position is remaining constant, or in other words not changing with respect to time, then we will say that particular object is basically at rest. And if its position is changing with respect to time, then what do we say? We will say that this is in motion. Okay, so in this chapter we are going to be discussing about the concept of motion. So if you look at how do we understand the idea of rest and motion in quantitative aspect, like say for example whenever we talk about position, right, how do we represent the position of an object? If we consider the object to be like a point object means what? It will not occupy any volume, it will be located at a single point. So we can give the coordinates of the point where the object is located. Okay, so let us say x comma y comma z represent the coordinates of the point. Okay, so every point in space can be given by these coordinates. So we'll call them as what? These set of three coordinates, we'll call them as Cartesian coordinates. Okay, the ones that will come from the x, y, z coordinate system. Now if you want to express the position of any location using a vector, we will express the position of any location using what we call as the position vector. So generally when we talk about the position vector, we are talking about the position vector with respect to origin. Means if we want to represent the position vector of the point P, then how do we represent it? We will draw a vector starting from the origin meeting at the particular point. So this will represent what? R bar, which we call as the position vector of the point. So R bar can be expressed as what? About this we have discussed in the vectors videos, right? So R bar can be expressed as xi cap plus yj cap plus zk cap. Okay, so x comma y comma z are what? The coordinates of the particular point P. So this will be the position vector. So what do we call R bar as? R bar will be called as what? Position vector. So we can define rest and motion like this. If the position vector of the particular point is not changing, if this R bar is not changing with respect to time, then we will say what? The object is at rest. Instead, if this R bar is changing with respect to time, if it is changing with respect to time, then what do we say? It will be in motion. When R bar will change, let us say it is moving from here to here, imagine, then obviously the location will be something else, maybe x dash, y dash, it will be some other, it will have some other values. Okay, so then what do we see? The position vector is basically changing. We can call it as what? R dash bar. It will be different value. Okay, so this is what we understand from the concept of rest and motion. So whenever the position of the object is fixed, not changing, we will say the object is at rest. When it is changing with respect to time, means this is a motion. Okay, and how do we understand this in terms of the position vector concept? If the position vector is remaining the same with respect to time, the object is said to be at rest. If the position vector is changing with respect to time, then the object is said to be in motion. Okay, now whenever there is a motion, the next question is how do we measure the motion? So when we want to measure the motion, right, we will basically have two parameters to measure the motion. So one is what we call as distance, and the other one will be displacement. First we'll talk about the distance. Say for example particle is starting from location A and reaching location B. Okay, it will go in a path. It will go from A to B in a particular path. The path may be a straight line. The path maybe, it can go in different paths. Okay, it can go in a straight line like this also, or it can go in a curved path, or it can go, okay, this is also a path. It can go in different paths. Okay, it can be path 1, path 2, path 3, like that. Okay, now whatever is the path that the object is covering during the motion, the total length of the path, covered, right, is what we will be calling as the distance. So since it is a length, right, what will be the SI unit of this? SI unit is going to be what? Meter. And what will be the dimensional formula? Because this is representing length. No, so dimensional formula will be what? Capital L. So this is about the distance. So what is distance? It is the actual length of the path covered by the object. Okay, so if it is going through path 1 means it will be what? The straight line distance from A to B. If it is going in a path 2 means what? It goes in a path 2 means, maybe I'll use a different marker to indicate it. So if it is going in path 2 means what? We have to measure this entire length of the path taken by the object. Okay, if it is going in path 3 means what? Again, we have to measure the entire length of the path taken by the object. Like this, we have to measure the entire length. So what we see is that distance is going to be depending upon the path taken by the object. Distance will depend upon what is the path taken by the object. And one more thing is what, this distance is just a value. So when we say that no, the distance covered by the object is 20 meters, it is just expressed by using the value. Remember in vectors and scalars discussion, we talked about it. So physical quantities which can be expressed just by their value, right? What do we call them as? We will call them as what? Scalar quantities. So the speed is, the distance is what? It is a scalar quantity because we can express the distance just by the value. Like, we'll say the distance covered is maybe 20 meters, 15 centimeters. Like that, we can give the values just in terms of the length covered. Okay, so we don't need to express the direction part. And if the units are not given in terms of meters, they can be given in terms of centimeters. I mean, if the values of the distance covered are lesser, they can be given in terms of millimeter or even micrometer, nanometer, like that. Okay, higher values means what? We can be given the values in terms of kilometer, mile, etc, etc. Okay, so we'll have to use appropriate conversion factor. Like in units and dimension chapter, we talked about what are the different units of length and how do we convert the value from one to another. Maybe when there is a problem, we'll look at it. Okay, so how do we do the conversion? But if the units have to be converted from one system to another system means we should be able to do the conversion by using the appropriate conversion factor. Okay, so this is the idea of distance. So distance is one way of measuring the motion of an object. Now the other way of measuring the motion of the object is by using the concept of displacement. So what is this displacement? So let us say the object is, again, I'm saying it is going from point A to point B. It can go in any path. Let us say it is going in a path like this. It can be any path. Okay, we need not have to worry about what is the path taken by the object. Okay, now when we look at what is the initial point, it is the starting point, so which is A. Okay, and what is the final point or the end point? This is the B. Now if you look at what is the shortest distance from the initial point to the final point, means what? We are talking about the straight line distance. We are looking at what the straight line distance from point A to point B, and look at this value. This value is going to represent the magnitude of the displacement, because displacement is defined as a vector quantity. So the shortest distance between the initial point and final point, right, the shortest straight line distance, that is going to be representing what? The magnitude of the displacement. Okay, and the direction of the displacement, because what are we saying? Displacement is defined as a vector quantity. The direction of the displacement vector will be from the initial point to the final point. So what about the direction? Direction will be from where? It will be from the initial point to the final point. That is why we can see we are indicating the arrow from A to B, because A is the initial point and B is the final point. So this is about the concept of displacement. Okay, so generally the displacement value, right, we will express it by using the symbol S, but we'll put a bar above because it is representing what? It is representing a vector quantity. So S bar is generally the symbol we use to indicate what? The displacement vector. Okay, so we'll see that displacement, if you look at what is it measuring? It is measuring what? The shortest distance from A to B. So which means what will be the SI unit? It is also measuring only length, right? What will be the SI unit? SI unit is going to be what? It will be still the same meter. What about the dimensional formula? Dimensional formula is also going to be what? It is measuring the length, right? So it will be what? L. But the difference between the distance and displacement is what? Distance is a scalar and displacement is a vector. Okay, now we will see how the displacement is related to the position vector. So we'll see how the displacement will be related to the position vector, because position vector is also what? It is a vector quantity, right? So the displacement of the object and position vector of the object, right, they both will be related. So we will see that relation here. So when an object is moving from one place to other place, what is going to happen? Its position vector is going to be changing, isn't it? The position vector of the object is going to be what? Changing. So let us look at the case here. So we'll say the object is moving from A to B. Okay, so we'll have the origin. So what is this? So if you look at the initial position vector as R1, so when the object is at point A, the final position vector is given by what? R2. Okay, and how do we represent the displacement vector? Because what is the displacement vector? It is the vector represented from initial point to the final point, right? Means we have to represent a vector like this. Now we have to indicate, of course, the directions of R1 bar and R2 bar. What will be the directions of R1 bar? So the initial position vector will be from origin towards the initial point. The final position vector will be from origin to the final point. Okay, now when you look at this triangle here, right, we can see the triangle over here. Can we think of the triangle of vector addition? So what do we see here when we observe the triangle carefully? This is like one side of the triangle. This is like the second side of the triangle, taken in order. You can see R1, this is what? S bar. R1 and S bar, they are like what? The two sides of the triangle taken in order. Now what about the R2 bar? This is like the closing side of the triangle taken in the opposite order, reverse order. Remember the triangle of vector addition? If you are having two sides of the triangle taken in order, their resultant will be what? Closing side of the triangle taken in the opposite order, correct? Which means what? The resultant of R1 and S, it will be equal to what? R2. So we'll just rearrange. We will take the R1 to the other side. So what are we going to get? S bar is equal to what? R2 bar minus R1 bar. This is a very important relation. Whenever there is a change in position, the displacement vector is given by what? It will be equal to what? The change in the position vector. We can also write it as what? The displacement will be equal to what? Delta R bar, also like that we can write. Okay, it is nothing but what? R2 bar minus R1 bar. Final position vector minus initial position vector. Okay, so this is an important relation, and we will use it. We will use it while we are discussing the concept of velocity, and also we will use it while solving problems. So we'll just do one sample question. So let's see how we understand the relation between the position vectors and the displacement vector. So look at this. Let us say an object is moving in such a way that its initial position vector is 2i plus 3j plus k, unit is meter, and final position vector is 3i plus 2j plus 4k. So this is the initial position vector, this is the final position vector. Okay, Now the question is, find magnitude of displacement. What are we supposed to find here? We are supposed to find what is the magnitude of the displacement. So let us see how we are going to do. Straight away, what is the displacement vector given by the final position vector minus initial position vector, which means what? 3i plus 2j plus 4k minus, I will keep the units aside for some time because both are anyway in the meter, minus what is the r1? 2i plus 3j plus k. So look at it, 3 minus 2 is what? 1 into I is I. 2 minus 3 will come, which is what? Minus 1. So it will be minus j. 4 minus 1, which will be what? 3k. So this is what is our displacement vector. But what they are asking us to find, they are not asking us to find the displacement vector. They are asking us to find what? The magnitude of the displacement. Means for this vector we have to find the magnitude. So what is the magnitude of the displacement? Root of I component. Here what is I component? 1. So 1 square plus j component. J component is what? Minus 1. Okay, square will come. K component is what? 3. So what is it? Root of, this is 1 minus 1. If you square it means it will be also 1. 3 square means what? 9. So what is it totally? Root 11 will come. Okay, so this is about the magnitude of the displacement of the object. So like this we will be able to relate between the position vector and the displacement vector. Okay, let us see this question. A person moves 4 meter along east and then 3 meter along north. So first he is moving 4 meters along the east, then he is moving 3 meters along the north. What is the total distance covered and the displacement? See, to solve these kind of questions, right, we must first try to depict the motion by using a diagram, otherwise we will not be able to solve. So first what I'm going to do is I'm starting from A, imagine. Okay, here they are saying east and north. How do we represent east and north? Generally when they are talking about the directions east, south, north, west, like that, right, the convention that we follow is we will take the right side to be the east, so left will be what? West. Upward will be, upward means, you know, it's like, you know, the positive x, we can take it as what? The east. In that case, you know, negative x will be what? It will be the west. Then the positive y will be what? It will be the north. Positive y will be what? North. And negative y will be what? It will be the south. So this is how we will generally take the representation of the directions as a convention. Okay, so look at it. I am starting from point A. So he is moving 4 meters along east, means from here there has to be movement of how much? 4 meters along the east. Okay, so let us say we will reach point B. Then 3 meters along north. From point B, north means what? Upright. So we have to move how much? 3 meters along the north, so that we will reach point C. Now they are asking what is the total distance covered. Total distance covered means what? What is the distance concept? Distance is what? The actual length of the path covered, right? What is the actual length of the path covered? From A we are starting, we are covering this 4 meter here, and then here we are covering how much? 3 meter. So distance, what is the distance covered going to be? 4 meter plus 3 meter, how much it is? 7 meters. We got our answer. Distance will be equal to what? 7 meters. Now look at the other thing they are asking, displacement. Displacement means what? It is the shortest distance, straight line distance from initial point to final point. Remember guys, what is the initial point? Where are we starting our journey in the beginning? A. Where are we terminating our journey or ending our journey? At the point C. Means displacement vector is given by what? This one. So this is basically our displacement vector. Now here if you want to look at this length, it is like what? In this right angle triangle, the hypotenuse. So hypotenuse means what? That will be representing the displacement magnitude. So what is the displacement magnitude? It will be the length of the hypotenuse. What is the hypotenuse formula? It will be root of base square plus height square, right? Means what? 4 square plus 3 square. What is it? 16 plus 9 root 25, which will be 5. Unit is going to be what? Meters. Why? Because both the base and height are in terms of meters, right? So the displacement magnitude also is going to be what? In terms of meters. Okay, so this is how we will be able to solve questions on distance and displacement. Now we'll go to another question. An object moves from A to B along a circular path of radius 14 centimeter. So how is it moving? From point A, it is moving along a circular path of radius 14 centimeter. Is it going in a full circle? No, it is only covering an arc of the circle. It's only covering a part of the circle. That's what we call as what? Arc. Find the distance covered and the displacement. We have to find the distance covered and the displacement. Okay. So how do you find the distance covered? Distance covered means what? It is the length of the arc, isn't it? Remember guys, what is the length of the arc formula? L is equal to what? R into theta. But the theta must be in radians. The length of the arc is equal to what? R into theta, right? R is radius and theta is what? The angle in radians. Okay. So look at this here. The angle created by the arc is given as what? 60 degrees. 60 degrees. What is the value in terms of radians? We have to divide by 180 and multiply by pi. Remember, what is the conversion factor? Angle in degrees into pi by 180 will give us the angle in radians. Correct. So 61s are, 63s are. So how much it is? Pi by 3. If you have done some problems means we will be able to straight away recall this. 60 means what? Pi by 3. 45 means what? Pi by 4. 30 means what? Pi by 6. 90 means what? Pi by 2. Like that we will remember these values on top of our mind. Okay. So now all we are going to do is just come and substitute. R is what? What is the radius? 14 centimeter, right? So 14 centimeter into theta is what in terms of radians? Pi by 3. So look at this. 14 centimeter. Pi we can take it as 22 by 7. Pi we can take it as what? 22 by 7. Because we see that 7 will get cancelled. Otherwise normally we have two options, right? Either we can take pi as what? 22 by 7. Or we can take the decimal value 3.14. Here why are we choosing 22 by 7? Because we see that there is a 14 in the numerator. It will get cancelled. No. 7 ones are, 7 twos are. What is it? 44 by 3. Unit is going to be what? Centimeter. That is what is the distance covered. Distance covered is what? It is the length of the arc. What is the formula we are using? L is equal to what? R into theta. L is equal to what? R into theta. Okay. So we got our first step. Next, what are we supposed to find? We are supposed to find what is the displacement. Displacement means what? From here we have to look at what is the straight line distance from A to B. This is what is the displacement. Correct. This is what is the displacement. Now let us call this as what? O. O represents the center of the particular circle. In triangle OAB, observe this carefully. What is the triangle we are observing? OAB triangle. OA is what? Radius of the circle. OB is what? Radius of the circle. Means the corresponding opposite angles will be what? Equal, right? Means this will be theta, this will be theta. Now we have a rule. What is it? Sum of the angles in a triangle is what? 180. Which means 2 theta will be equal to what? 60 will go to that side. 180 minus 60 will be what? 120. Yeah. So 2 theta is 120. Means what? Theta will be equal to what? 60. So this is 60. This is also 60. Now what is happening? The triangle OAB is becoming what? It is becoming like an equilateral triangle. Correct. The triangle OAB is becoming like what? It is becoming like an equilateral triangle. Equilateral triangle means what? All angles will be 60 and all sides will be equal. Now OA is 14, OB is 14. So AB also will be equal to what? 14 centimeters. Why? Because the triangle OAB is an equilateral triangle. Okay. So what is AB? That is what we are looking for, right? That is what is the displacement magnitude. Okay. So what is the answer for the displacement? It is what? 14 centimeters. What is the displacement? It is what? 14 centimeters. Okay. So this is how we will be able to answer the questions on distance and displacement. Now let us look at the comparison between the distance and displacement. So we have some similarities and some differences. See, both will have the same SI unit, which is meter. Both will have the same dimensional formula, which is L. But distance is what? It is a scalar. What about the displacement? It is a vector. Means displacement we will associate both with magnitude and direction. But here, let us say we are starting our journey from point A and then reaching point B in this particular path. Look at this, this is the path. It's a general path, okay. I'm just representing one general, very general path. Now the thing is, this total length is what we are calling as the distance. Total length is what we are calling as the distance, correct. Now think about the straight line distance from A to B. What is this called as? This is what we are calling as the displacement magnitude. So why are we particularly using the word magnitude? Because whenever there is a vector, that value or the measurement is what we will call as the magnitude of the vector, okay. And vectors will always have the direction associated. So you see, the straight line distance, right, will always be, it will be always what, the straight line distance will be always less than or equal to the distance covered. So why are we saying this? So there is an important relation between the distance and the displacement. What are we saying? The straight line distance, which is the displacement magnitude, is always less than or equal to the distance covered. So why are we saying that? Think about it. So you fix a rope here. Imagine you fix a rope. You fix a rope which is, straight between A and B. Now think about pushing the rope little bit away. Will you be able to push the rope little bit away? Because if you fix it to the exact length, we will not be able to push the rope this side or that side, isn't it? But you take any other rope which is going in a different path between A and B, you adjust a rope which is going in a different path. What you see, always this rope, right, let's call it as rope 1 and rope 2. The rope 2 will be always having a longer length. The rope 2 will be always having a longer length. When rope 1 and rope 2 will exactly match, when they will exactly match, when rope 2 is also simply coming and aligning in the same direction, which means what, the distance value will be equal to the magnitude of the displacement when the object is moving from one point to another point in a straight line, without changing the direction. So this is important. What is it? When the distance and displacement magnitude will be equal when the object is going in a straight line without changing direction. So why are we saying like that? I'll explain. If you go in a straight line, right, then think about it. What is the length of the total path covered? This is the length of the total path covered, okay. And what will be your shortest distance from A to B? That is the displacement, right? Shortest distance will be what? It will be also the same thing, no? So that is the reason why when an object is going in a straight line without changing the direction, right, then the distance value will be equal to the magnitude of the displacement. But if it is going in a straight line but changing direction, imagine, so if it is going from point A to, imagine, point B, and then changing the direction and coming and finally ending up at point C, okay. Now if I ask what is the total distance covered during the journey, so what you have to say, the total length of the path covered, right? You can see the total length of the path covered will be what we have to, as it is going the same path, the entire red color marking will be what? The distance. But if I ask you what is the displacement, how do you represent the displacement? We will represent the displacement from the initial point A to the final point C, okay. So displacement is given by what? Displacement magnitude. Displacement magnitude is given by simply the shortest distance between A to C, that's it. So just because a particle is going in a straight line does not always mean that distance and displacement magnitude will be equal. When they will be equal, when the object or particle is going in a straight line without changing the direction of motion, okay. So only then the distance value will be equal to what? Magnitude of the displacement, okay. So we'll just write down the final result. What is the result? So we'll say distance covered during any journey, distance covered, right, will be always more than or equal to the displacement magnitude. It will be always more than or equal to displacement magnitude. Okay, so this is another important relation when we are comparing the distance and the displacement. Okay, now when there is a motion, we can study the motion, or rather we can observe the motion by using the concept of distance and displacement. But what if we have to compare the motion? Let's look at this particular visualization. I'm sure you guys know. So Usain Bolt, right? So he's the fastest man supposed to be on the earth. So when these 4-5 people are running, it's not like only one person is running. So if one person is running, what do we say? He is in motion. We can talk about the distance covered, we can talk about the displacement, etc. But if 3-4 people are moving, right, we obviously want to compare the motion of different people. Okay, so how do we compare the motion of different people? We'll compare the motion of different people by using two physical quantities. One is what we call as a speed, and the other is what we call as a velocity. So how do we compare the motion of different objects? We'll compare the motion of different objects by using either the speed or the velocity. We'll see how the speed is going to be measured and how the velocity is going to be measured. Okay, but when we are comparing, right, we will be using the already existing parameters to study the motion. What is it? Whenever there is a motion, we said we can study the motion by using either the distance or displacement. When we want to compare the motion of the objects, right, along with the distance and displacement, we will bring in the aspect of time. We'll bring in the aspect of what? Time. So when we're talking about the definition of speed and velocity, right, we'll bring in the concept of time. So let us see what is the speed first. So speed is defined as the rate of distance covered. It's a very simple definition. What is it? It's defined as what? Rate of distance covered. Means what? Speed will be equal to distance covered by the time taken. So how do you define the speed? Distance covered by the time taken. So look at it. So distance covered is a scalar quantity. Time is also what? Scalar. So thereby the speed also becomes what? Speed is also a scalar quantity. Okay, and distance, what is the SI unit of distance? It is meter. Time, what is the SI unit? Second. So the SI unit of speed is what? Meter per second. We can also write it as what? M s to the power of -1. What about the dimensional formula? See, remember, whenever we are talking about any physical quantity, the first things that we need to be focusing on are, of course, what is the definition of the physical quantity. The moment we understand the definition of the physical quantity, we should try to look at what is the SI unit of the physical quantity and what is the dimensional formula for the physical quantity. Okay, so look at what will be the dimensional formula for the speed. What is the distance dimensional formula? Length, L. What is the time dimension formula? Capital T. So L T power -1. This is the dimensional formula for the speed. So this is how we are going to define the quantity speed. Speed is generally represented by the symbol V. Speed is generally represented by what? The symbol V. Okay. Now let us talk about the velocity. So velocity is defined as the displacement in unit time. How do you define the velocity? Displacement in unit time. Means what? Say for example, we talk about the displacement value of some s, because velocity is what? It's a vector quantity and it is indicated by the symbol v bar. So when we generally say v, we are talking about the speed. When we put v bar means what? We are talking about the velocity. Okay, so it will be what? Displacement in unit time. Means we have to divide this by what? Time taken. So this is the formula we have for the velocity. Velocity will be what? Displacement by the time taken. And what is the displacement? Displacement is given by what? Change in the position vector. Remember, displacement is given by what? Change in the position vector. So we can also write it as what? Change in the position vector. And also write it as what? Change in the position vector by the time taken. Okay, and velocity is a vector quantity. Velocity is what? It's a vector quantity. And one thing here, it's like what? If you try to understand the relation in terms of vectors, it is like we are multiplying a constant 1 by t with s bar, like that. Means here we are multiplying a positive constant. We are multiplying a positive constant to displacement vector. Remember, when we are having like this, a bar is equal to some constant k into b bar. If the k is a positive constant, right, then a bar and b bar will be in the same direction, isn't it? So this is what we have discussed in the properties of the vectors, multiplying a vector by a scalar constant. Same way here, since time is a positive constant, right, which means what? The velocity will be in the same direction as the displacement vector. Velocity will be in the same direction as the displacement vector. Okay, so this is about the way in which we will measure the velocity. It will be a vector quantity. It will have units. What will be the SI unit of this? Because the displacement, what is the displacement SI unit? Meter. Time, what is the SI unit? Second. So the SI unit of the velocity is also what? Meter per second. What about the dimensional formula? What is the displacement dimensional formula? L. What is the time dimensional formula? T. So what is it? LT power minus 1. So here also we will see the speed and velocity, they have the same SI unit and also they have the same dimensional formula. Okay, so this is the way in which we will measure the velocity. And one more thing is, velocity vector direction will be in the same direction as the displacement vector. Let us talk about the comparison between the speed and the velocity. So what did we say? We said the speed and velocity, they have the same unit. So we'll talk about the similarities, and also they have the same dimensional formula, but we have some differences. What are the differences? Speed is a scalar because it is defined by using distance. What about the velocity? Velocity is a vector because it is defined by using what? Displacement. Now remember, we have a relation between the distance and displacement. Distance is what? Always more than or equal to the magnitude of the displacement. We'll divide both sides by time. We'll divide both sides by what? Time. So what is the distance by time? Means speed. Speed will be always more than or equal to what is displacement by time? Means velocity, right? So which means what? Speed is always more than or equal to the magnitude of the velocity. So speed is always more than or equal to what? Speed is always more than or equal to magnitude of the velocity. When they both will be equal? When the object is going in a straight line without changing its direction. Okay, so this is what we have as the comparison between the speed and the velocity. Okay, now whenever we have the idea of comparing the motion of 2 or 3 objects, we can do it by using speed. At the same time, we can also do it the comparison by using velocity. But as we go on, right, you will see that we will be using velocity more often to compare the motion of the objects than the speed. Okay, we will come to know about the reason also. Why do we use more velocity to compare the motion of the objects? We look at this question. A person completes one full circular rotation. Means what? If you look at a circle, one full means what? Starting from A, you go in the circular path. Okay, you go in the circular path and come back to the same point A. That is what we mean to say by one full circular rotation along a perimeter of a circle having radius 21 meters in 10 seconds. What is the radius of the circle? 21 meters. What is the time he is taking for that? 10 seconds. What is his speed and velocity during the journey? What is his speed and velocity during the journey? So look at this journey, right? Starting from one point A, he is covering the entire perimeter. What is the perimeter formula? 2 pi r means what? 2 into pi, we will take it as 22/7. Why? Because r is given as what? 21 meters. We will see there is a cancellation. 7 ones are 7 threes are. Okay, so what is it? 2 into 22 is what? 44. 44 into 3 is what? It will be how much? 44 into 3, it will be 132 meters. So this is what is the perimeter. And what is this perimeter representing? It is representing the distance covered by the person, right? Because he is going from point A, he is going all along this perimeter and coming back to the same point. Okay, so which means what? The total length of the path covered will be what? 132 meters. So what about his speed going to be? Speed is what? The total distance covered by the time taken, which means what? 132 meters is the total distance, divided by time taken is what? 10 seconds. How much it is? 13.2 meter per second. What is the value? It is what? 13.2 meters per second. Okay, so this is what is the speed. Now let us talk about the velocity, because we are also supposed to find what is the velocity. Now to find the velocity, right, we should talk about the displacement. See, where he is starting? He is starting from point A. Where he is ending, he is also ending at the same point. Starting, he is going in a particular journey and then he is coming back. Means the starting point, ending point are what? Same. So in this case, if the starting point and ending point are same, means what? The displacement. What will be the displacement magnitude? It will be equal to what? 0. The displacement magnitude will be equal to what? 0, because starting point is same as ending point. You try to draw the shortest line between them, you cannot draw a line because that is the same point, right? So the displacement magnitude is equal to what? 0. So as a result, what will be the velocity? Velocity will be equal to what? 0. So here we have an interesting thing. There is a motion here. He is going in a circular path. When there is a motion, for the entire journey, it is possible that we have a distance covered, but displacement can be 0. We have a distance covered, but displacement can be 0. So if you want to conclude whether there is a motion or not, the first thing we need to look at is what? Distance covered. Why? Because distance covered will tell us whether there is a motion or not. Looking at the displacement value, right, we may not be able to conclusively tell whether there is a motion or not. Why? Because here in this case, look at it, displacement is coming as 0. Can we say whether there is a motion or not? Because if the person is not moving from his initial point, then also the displacement will be what? 0. He has gone in a circular path, come back to same point. Displacement is what? 0. So if you want to conclusively tell whether there is a motion or not, what is the term that can represent the motion? It is the distance. Why? Because distance will tell clearly whether there is a motion or not, because the moment he steps out, we will start measuring the distance. But in the entire journey, like in this case we are seeing, right, distance can still be 0. When it will be possible? When the initial point and the final point of the journey are same, then the total displacement of the journey can be equal to what? 0, like this. Okay, so this is how we'll have questions between the speed and the velocity. And one thing here we need to understand is the speed and velocity that we are measuring here, right, we will be calling them as the average speed and average velocity. What do we call them as? Average speed and average velocity. So why do we use the word average speed and average velocity? Because we are taking a finite time interval, like say 10 seconds of the journey, 5 seconds of the journey, 4 seconds of the journey. So we are taking a finite time interval, and in that we are looking at what is the distance covered, dividing the distance covered by the time taken, or we are looking at what is the displacement and dividing the displacement by the time taken, like that. There is one more way of defining the speed and velocity, which we will call it as instantaneous speed and instantaneous velocity. What is it called as? Instantaneous speed and instantaneous velocity. Okay, so we will see how we will talk about the instantaneous speed and instantaneous velocity. So I'll just take the example of that Usain Bolt, that particular 100-meter race. So let's say all of them, they'll start from the point where the journey is beginning, and they will all come to the final point. This is the final point. Okay, this is the starting point and this is the final point. Now to cover 100 meters, right, typically Usain Bolt will be taking, I think, 9.2 seconds or something like that. So I mean, I'm not sure about the exact time he has taken, but for the sake of simplicity, right, because we want to just understand the concept, let us say he is taking 10 seconds to complete the entire journey. In fact, he's actually taking lesser amount of time. Okay, so he's taking 10 seconds, imagine. Then the total journey time, right, will be what? 10 seconds. In the 10 seconds, how much distance he is covering? Because obviously the 100-meter race we will consider it as like what? Straight line. So the distance covered and the magnitude of the displacement will be what? Same. Let us talk about distance itself. So he's covering how much distance here? He's covering a distance of 100 meters. So for the entire journey, if I measure the speed, what is the speed? It will be the distance covered 100 meters by the time taken 10 seconds. What is it? 10 meter per second it is coming. What is it coming as? 10 meter per second. But if I break down the journey into small time intervals, what do you mean by breaking down the journey? So look at it. I will break down the journey into 10 intervals, imagine. 3, 4, 5, 6, 7, 8, 9. Okay. So this is 1 second, another 1 second. You can see how many will be there. We'll actually have 10 intervals. Total 10 seconds we are breaking it. Now in the first 1 second, right, just when the gun is shot, so they usually shoot a gun to start the 100-meter race. Do you think they will be picking up their best speed? That's when they are starting. Practically when you observe, right, he might be covering only a distance of maybe 3 meters. So in this time interval, if you look at what is his speed, what you will have to say, the distance covered is 3 meters, and what is the time here? 1 second. So his speed will be what? 3 meter per second. In the next 1 second interval, he might cover some 8 meters. It will be what? 8 meter per second. His speed in this interval. In the next 1 second, he might cover some 10 meters. So here it is what? 10 meter per second. In the next 1 second interval, he might cover some 12 meters. So what will be speed? 12 meter per second. Here he might cover 14 meters. What will be the speed here? 14 meter per second. Here he might cover 16 meters. What will be the speed? 16 meter per second. I'm sure if you happen to look at the Usain Bolt running race, right, he has this characteristic move that is just before the finishing line, right, he'll actually slow down. Okay, so if you want, just go and take a look at some of his videos. So he'll little bit slow down. Maybe in the last 1 second he might be just covering some 8 meters. Okay, people wonder as to why he's slowing down. So what is the speed there? 8 meter per second. So the point is, in the entire journey, the speed is not this 10 meter per second we calculated. What is the average speed for the entire journey? Total distance is what? 100 meter divided by total time is what? So what is the average speed for the entire journey? 10 meter per second. If you break the journey into small intervals, what is happening? In each interval, the speed is what? Changing. Now we will do one more thing. Let us break this first 1 second interval also into two parts, 0.5 seconds and 0.5 seconds. Do you think he will cover 1.5 meter and 1.5 meter? No. Initially when the race is beginning, he would take some time to respond. So maybe what happens, in the first half a second he might be covering only 1 meter. Second half a second he might be covering 2 meters. Thereby totally in the first 1 second is becoming what? 3 meters. Now if you look at the speed here, distance is what? 1 meter, time is 0.5 seconds. So speed will be what? 1 meter by 0.5, which will be 2 meter per second. Here it will be what? 2 meter by 0.5 seconds. It will be what? 4 meter per second. So when you want to understand the real speed at a given instant of time, we have to keep breaking down the time interval into smaller and smaller values. And this way, to what extent we can go, how much we can break the time interval, We can break it into such a small value that we can't even measure how small it is. And that is what, remember, in the basic mathematics videos we talked about it. What is it called as? Differentially small time interval. What do we call it as? We will call it as what? Differentially small time interval. How do we represent it as? We will represent it as, how do we represent? We will represent it as what? dt. What is this dt representing? Differentially small time interval. In that very small time interval, I mean, we can't even measure how small it is. In that very small time interval, if we look at what is the distance covered, we look at what is the distance covered, it will be also what? Small. Let us represent this by what? ds. Small distance covered in that very small time interval is what? ds. Then the speed will be equal to what? ds by dt. First we'll understand how this instantaneous speed, what do you call it as? Instantaneous speed. We cannot get it just like that. We will be able to find out this value by either using the differential method or by using the graphical method. So how are we going to get this instantaneous speed value? Either we will get it by using what? Differential method or by using the graphical method. So we'll discuss about it when we go to the specific problems on that. But here we'll try to understand the concept of what is instantaneous speed. Means we have to take such a small time interval which we cannot even measure. That is what we are indicating with what? dt, differentially small time interval. In that small time interval, let us say the distance covered in that is what? ds. Then that distance covered by the time taken, we cannot directly measure it. That's what I'm saying. How do we get the value of the instantaneous speed? Then we'll get the value of the instantaneous speed by either using the differential methods or by using the graphical methods. We'll get it by using what? Differential method or the graphical method. We'll talk about it when we go to the specific problems. We'll talk about it, but here we are just trying to understand what is the meaning of the instantaneous speed and instantaneous velocity. Okay, now we have talked about the instantaneous speed. Let us talk about the instantaneous velocity. It is also defined the same way. We have taken that very small time interval dt. In that, look at what is the small displacement. We are calling it as what? ds bar. Why we are putting a bar? Because it is the displacement. It's a vector nevertheless. So that small displacement by the time taken, that is what? Instantaneous, what is it? Instantaneous velocity. And remember, this also we cannot find the value directly. We have to get the value of the instantaneous velocity. How? Either by using the graphical method or by using the differential methods. Okay, we'll talk about it when we go to the specific problems on that. Okay, but here we are trying to understand what is the concept of the the instantaneous velocity. Now the thing is, when we look at that very small time interval, the distance covered or the displacement, they will be almost like a straight line path, isn't it? It's so small that we can't even measure it. So can we say it is almost like a straight line path? We cannot think about a curve and all that there, which means what? The distance covered in that small time interval will be equal to what? The magnitude of the displacement, because both are, the displacement is happening in the straight line. So as a result, what we'll have? The instantaneous speed will be equal to what? Magnitude of instantaneous velocity. Because remember, when we said speed will be equal to magnitude of velocity when the object is going in a straight line path without change direction, the time interval is so small that can you think about a curved path and all there? No, it will be the distance covered or the displacement value. We cannot even measure how small it is. So we can almost think of it like what? Possibly straight line motion, which means what? The instantaneous speed will be equal to what? Magnitude of the instantaneous velocity. Okay, so this is about the concept of instantaneous speed and instantaneous velocity. The average speed and average velocity, we were able to straight away measure it. Like they will give us problems like that. No, the journey, this is the distance, this is the time, and this is the displacement. We can find what is the average speed and average velocity for that journey, where the time interval is what, finite. But instantaneous speed and instantaneous velocity, we cannot just like that get the values. So we have to get the values by using either the differential approach or the graphical approach. Okay. Now we'll go to another important parameter to study the motion of object, which is the acceleration. Now acceleration rate is the link between the motion and we'll say cause of motion or cause of change of motion. You know what we're talking about here? Force. Acceleration is the link between what? The motion. So whenever there is a motion, we'll study the motion by using what? The parameters of motion, which is distance, displacement, or speed and velocity. Acceleration is the link between the motion of the object and the cause of motion or the cause of change of motion. So what is that cause of motion or cause of change of motion? Force. We'll talk about this in the Newton's laws of motion chapter, how the force will be able to cause the motion or how the force will be able to cause change of motion. Okay, so how this acceleration first of all is defined. So acceleration is defined as a rate of change of velocity, which means what? Let us say if u, I'm always putting a bar because what, all these are vectors, u bar is the initial velocity, v bar is what? The final velocity of the object. Then rate of change of velocity means what? Change in velocity, final minus initial divided by the time taken, t. Or you know, we can also represent this by what? Delta t, change in time, like that we say. Okay, either t we'll put or we'll put delta t. Okay, now this can be also expressed as what? Delta v by delta t, because delta v supposed to means what? The change in the velocity. Okay, so either we'll say final velocity is v and initial velocity is u, or we can even say initial velocity is v1, final velocity is v2. In that case, what we will have? It will be what? v2 bar minus v1 bar is what? Change in the velocity. So rate of change of velocity is what we will call as what? Acceleration. Now look at this. If you see what is there in the numerator? Change in the velocity. What is the velocity unit? SI unit is what? Meter per second. Denominator, what is there? Time, which means the SI unit of acceleration is what? Meter per second square. We can also write it as what? M s to the power of minus 2. Okay, what about the dimensional formula? What is there in the numerator? The change in velocity, means velocity. Dimensional formula is what? L t power minus 1. Denominator is what? Time. So look at it. What is the final dimensional formula? L t power minus 2. That is the dimensional formula for the acceleration. Now this definition, delta v by delta t, right, is actually, you know, definition for what? It is the definition for the average acceleration for the journey. Why? The way we have talked about the average speed and average velocity, instantaneous speed and instantaneous velocity, same way here also, when we look at the change in velocity in that entire, say 10 seconds or 5 seconds, whatever the entire time, divide the change in velocity by the total time of the journey, what are we going to get? We will get the average acceleration, like the way we got average speed and average velocity. We can also define instantaneous acceleration. What will be the instantaneous acceleration? We have to take the time interval value to be what? Very, very small. How small? We cannot even measure how small it is. So that is what we call as differentially small time element. What is it? dt. What is the differentially small time element? It is what? dt. Okay, now in that small time interval, which we cannot even measure, and that is the reason why we are going to use what? The differential methods. So we take a very small time interval dt. In that, let us say the change in the velocity is given by what? Here we also express the notation d, because this change in velocity will be also what, very small, differentially small change in the velocity. This is what the small change in velocity during the time interval dt. So during the time interval dt, this is the small change in the velocity. Now what will be the average acceleration definition going to be? That whatever the small change in velocity divided by that small time interval dv by dt. Again, how are we going to get these values? Either by using the differential method or by using the graphical method. We will get the instantaneous acceleration value by using what? Either the differential method or by using the graphical method. Okay, so this is how we will define the average acceleration and instantaneous acceleration. Average acceleration is for what? For a finite journey time interval. Instantaneous means what? When the time interval is very small. I mean, you know how small we'll take? It's a differentially small time interval, like that. Okay, so this is what is about the definition of the average acceleration and instantaneous acceleration. So now that we are discussing about the acceleration, let us just try and do one sample question on this so that we'll understand how good we are able to get this concept. So let us say the initial velocity of the object is given by 2i plus, the initial velocity is 2i plus 3j meter per second. Final velocity is 4i plus 4j meter per second. Okay, the time taken for the change in velocity. So what is the time taken for the change in velocity? 2 seconds. Find average acceleration of the journey. What are we supposed to find? We are supposed to find what is the average acceleration of the journey. Okay, so let us see how we'll solve it. How do we solve it? So what is the average acceleration formula? Change in velocity. Velocity is a vector, we have to keep that in mind, divided by the time taken. Remember what I said? We can either put delta t or simply t also, both are acceptable. So what is this? Final velocity is what? 4i plus 4j meter per second minus what is the initial velocity? 2i plus 3j meter per second divided by what is the time? 2 seconds. So what is it? 4 minus 2 is what? 2i, and 4 minus 3 is what? 1j. Whole divided by 2 is there, meter per second square. We can write as what? It will be what? I plus half j. If you divide by 2, what we are going to get? I plus half j meter per second square. This is what is the average acceleration for the journey. All we are doing is what? Just do final velocity minus initial velocity by the time taken for the journey. That's it. Okay, so this is how we are going to work out the acceleration problems, provided it is about what? The average acceleration. As I said, instantaneous acceleration we cannot find by using methods like this. We have to get the value by using what? The differential approach or the graphical approach. Now when we look at the motion, we'll generally divide the motion into some types or categories. Okay, so if the speed is remaining constant for any object, if the speed is remaining constant, we will call it as what? A uniform speed. The word uniform represents what? Same, uniform speed motion. If the speed is remaining constant, what do we say? Uniform speed motion. If the velocity is remaining constant, then we'll say it is what? Uniform velocity motion. So we'll study about them, each of them in detail. So first is what? If the speed is remaining constant, what do we say? Uniform speed motion. If the velocity is remaining constant, what do we say? Uniform velocity motion. We'll study about them in detail. If the acceleration is remaining constant, then we will say it is uniform acceleration motion. If the acceleration is variable, means it is changing, we will say it is non-uniform acceleration motion. Okay, so generally when we have the JEE mains level, right, we'll get questions from uniform speed, uniform velocity, uniform acceleration. JEE advanced, we'll have questions touching on this non-uniform acceleration motion concept. Okay, so where we'll have mostly the applications of integration method and the differentiation method. Okay, so these methods will come into the application when we talk about the problems in variable acceleration motion or the non-uniform acceleration motion. Okay, so these are the types of motion, and as we go into the further lectures of this chapter, right, we'll discuss about each of these types of motion in detail. Okay, now while we talk about the types of motion, we also have study of motion in different manner. So when it's a study of motion, right, here we talk about whether it is a motion along one dimension, or whether it is a motion along two dimension, or whether it is a motion along the three dimension. Means what? Think about it. If a body is moving in a, so this is what we call as, the way in which we will study the motion. So if the body is moving in a straight line, then we will say it is one dimension. You know why? Because we'll see that only one coordinate of the particular object location will be changing. Means, remember, if it is moving along x-axis means what? Think about it. If it is moving along x-axis means what? Only the x coordinate will change, y and z values will not change. So only one coordinate of the position of the body changes with time. Then what do we say? It is moving one dimensionally. It may be along the x-axis, it may be along the y-axis, it may be along the z-axis, or it may be along any straight line also. So what do we say? We'll say it as what? One dimensional motion or straight line motion. Okay, so this is one way in which we will look at the motion. So 1D motion. What will be the examples? Like, if you look at an object which is vertically falling down, we can see here. Okay, these two objects are actually vertically falling down. Okay, so we'll call it as what? We'll also call it as a free fall. So we'll throw a stone upwards, we'll drop a stone from top, or we'll throw a stone from top. Like, this is all what? Examples of the vertical straight line motion. We can also have a horizontal straight line motion. Like, look at it. We have a straight road, imagine, and there is a car going on the straight road. Approximately we can take it as what? This is like a straight line motion. Okay, so we'll talk about the 1D motion. In fact, this chapter itself is what are we naming the chapter as? We are naming the chapter as what? Motion in one dimension, which means we are going to be particularly focusing on this one dimensional motion. Okay, then we can have the motion of an object which is in two dimension, or we'll say motion of an object in a plane. So if the motion of the object is in a plane, then we'll say it as what? A two-dimensional motion. So 2D means what? Look at it now. Imagine if the object is moving in the xy plane, then what happens? The x coordinate of the particle changes, y coordinate also will change, but z coordinate will not change. If the object is moving xy plane means what? X coordinate will change, y coordinate changes, but z coordinate will not be changing, it will be constant. So when two coordinates of the position of a body will change, then what do we say? We'll say it is a 2D motion or two-dimensional motion. The best examples are what? Motion of a car in a circular term. Why car? Any object you take, look at this now. If it is going in a, this is what? This is the circular motion. It is an example of what? It is an example of the 2D. You can see that object, blue color object, is going in what? Circular path. We'll discuss about it when we go to the study of two-dimensional motion. We can have motion of billiard ball on the billiard ball table. When you are hitting the ball, right, you'll see that the motion will be what? On the billiard ball plane, the table plane, it will be happening. That is why it is what? A 2D motion. And we are going to study in detail about this projectile motion. In 2D motion topic, we will study about what? Projectile motion. You can see here there is a ball going like this. What is it called as? We will be calling it as oblique projectile. We will study about them when we go to the 2D motion. So projectile motion is one of the very important examples of the two-dimensional motion. Then we can also have motion of the object where I mean, the object can be moving in space. Generally, if you look at, see, you're sitting in a room, imagine, okay, so let's say you are sitting in a room and you see there is a fly going in the room. So how does the fly, or that house fly or whatever it is, right, how does the fly or mosquito go? It will travel in space. Means what? The motion of the body which is in space, it will be what? Three-dimensional motion. In that, all the three coordinates of the position, means what? X coordinate, Y coordinate, all of them will be what? Changing. All of them will be what? Changing. That is what we call as the three-dimensional motion. In short, we call it as what? 3D motion. We can also call it as what? General motion. General motion means what? We'll consider that, you know, all the three coordinates can be changing. What are the examples for that? As I said, motion of the flying insect and motion of flying kite. I'm sure, you know, when the Pongal comes, most of us will fly these kites, right? So you'll see that, you know, in the air, when the kite is flying, we'll see that, you know, the motion will be what? It's a motion in space. We call it as what? A 3D motion. Okay, so this pic is just to remind one of the popular movies, okay, so where they'll play these, you know, kites in one of the introduction songs. Anyway, so this is what is the three-dimensional motion. So when we talk about the motion, right, either we can have the motion of the object confined to one straight line. That is what we call as motion in one dimension, and that is what we are going to study in detail in this chapter. We can have motion which is happening in a plane. We'll call it as what? Plane motion or 2D motion. We can have a general motion in space. We'll call it as what? 3D motion. Okay, and in this chapter, as I said, we are going to be focusing on the motion in one dimension. Okay, we'll see in the next video.